Welcome back to True North Mechatronics. With the sides and top of our Vetronics enclosure locked in, we're turning our attention to the split back cover. The rear cover is divided into two distinct components, a switch panel and the port access cover. The switch panel mounts directly to the Vetronics platform and features a profiled pocket for our main rocker switch alongside a mounting socket for an LED. The port access cover interlocks with the top and sides of the Vetronics enclosure. Because this rear cover swings down within millimeters of the Arduino Uno, we need to add deep cutaways into the bottom edge so it clears the USB and barrel jack without collision. Design, engineer, deploy. Let's get into the CAD. Begin by creating a new body and a new sketch on the XY plane. And we're going to use the polyline tool and we're going to rough out the basic shape of our port access cover. We're going to have 3 tabs on the top that will interlock with the top of the Vetronics enclosure. And we're going to have 2 tabs along the side, and these will connect into the side of the Vetronics enclosure, and it will just keep this back panel from moving. We've got our barrel jack access port that we include here, and then we also have a port that allows us to access the USB connector. All right, our next step is to find any line that wasn't automatically horizontally or vertically constrained. We have a couple of them here. It looks like all of them, so we'll constrain them horizontally and vertically. Next, we are going to set these 3 tabs on the top so that they are equal in length to each other. We're going to set the stepped space between the tabs so that they're equal to each other. And we're going to make this center tab so that it's symmetric around the y-axis. Then we're going to make sure that these tabs that connect on the side, we're going to make sure that they are also set so that they are equal to each other. They're going to be a slightly different length than the top tabs. Now we're going to make it so that all the edges of these tabs are equal in length. So we're going to select all the tab edges. And we'll set them equal to each other. They're all going to be the thickness of 3 millimeters. And with that, we have we've set much of the main constraints. So I'm going to hide the collection of constraints that we created so far to give us a clearer view of the geometry. And we're going to set this internal step here to 3 millimeters. And this feature here, we're going to set to 9.25 millimeters. Bring that out so it's a little bit easier to see. We need to shrink in our side profile here a little bit. Let's set the length of our tabs now. So these are going to be set to 10 millimeters. Bring in our profiles that we created there. Zoom in just a little bit. All right. Our tabs on the side, they're going to be 8 millimeters in the vertical dimension. And we're going to set the space between these 2 tabs here at 14 millimeters. And now let's set the height of our overall panels. We're going to set that to 47 millimeters. Going to adjust the location of our features here. All right, now let's take and set the dimension for this segment here. So that's 6.5 millimeters. And now we're going to set the constraints for our port access holes. So our barrel jack is going to have a step over feature length of 8 millimeters. We're going to set the length of the barrel jack access to 17 millimeters. And we're going to set the width of this port access to 10 millimeters. The USB port access is going to be 18 millimeters high. And we're going to set it to 16 millimeters long. And let's set it in by 16.5 millimeters from the edge. All right, so with that, we have fully constrained the basic shape of our rear port access panel. This will be the back side of our enclosure for the Vetronics stick. So let's close out of the Sketcher workbench, and we're going to pad this shape out by 3 millimeters. Next, we're going to add some venting slots here at the back. They're not necessary, they're more cosmetic. They do reduce the amount of plastic used for producing this part. So let's come in, and we're going to use the slot tool. I'm going to create 2 slots here. And I'm going to create 2 more slots over here. And I'm going to create 1 slot over here. All right, so you can see that each one of these slots has been vertically aligned. So we want that. If you didn't end up with the vertical alignment lock, then you're going to have to add that. Let's make the tops of all of our slots so that they are collinear. So we will select the top point there, and we will lock them into the same horizontal plane. We're going to make these slots so that they are all of equal thickness. We'll do that by setting the radius on the bottom arc. Set them all equal. And we're also going to set the lengths of these slots so that they're all equal as well. All right, now that we've done that, now we can start adding some dimensional constraints. So I'm going to hide the current set of constraints to give us a clearer view of the geometry. And the first thing I'm going to do is I'm going to constrain this bottom arc out to 1.5 millimeters. Now we're going to set the point-to-point distance on that first set of arcs to 7 millimeters. We'll do the same with the second set. Now we'll set the lengths of our slots to 11 millimeters. And we need to position where these slots are going to sit, and we're going to do that by referencing this left-hand edge here, this inside right edge, and this inside right edge. And we're going to select the outside of the slot as our reference point. And we're going to set this to 3.25 millimeters. That will position this set of slots in the center. We're going to follow the same process over here, so 3.25 millimeters. And this one is centered in its spot with a offset of 2.5 millimeters. All right, now we're going to position these slots with respect to the bottom of our shape. So we're going to set that to 7 millimeters. And with that, we have fully constrained these venting slots on our rear cover for our Vetronics enclosure. So we can close out of the Sketcher workbench. We're going to pocket these through. Next, we're going to view the back side of our platform here, and we're going to create a sketch on the back. I'm going to come to the bottom left-hand corner with respect to our current view. And with the rectangle tool, we're going to add a rectangle here in the bottom corner. Make sure that you don't actually click on the terminating vertex at the end of that line. Otherwise, you'll have to remove the coincident constraint. Let's set this to 5 millimeters in the vertical and 8 millimeters in the horizontal. This will be padded out in our next steps, and this will become a mounting boss that we will attach to the rear cover. All right, so let's close out of that, and we're going to pad that out to 5 millimeters. And now we're going to view the bottom of this, and we're going to create a sketch on that face there. Zoom in, and make sure that you don't click or connect to that x-axis, because you will have a constrained coincident there, and you will have to remove it. Let's reference the bottom edge of our mounting boss, and we're going to offset this circle from one side by 4 millimeters, and then we will offset it from the bottom, and that will be 3 millimeters. All right, so our hole is positioned. We just need to constrain its diameter, so we're going to constrain it to 2.8 millimeters. And now we can see that our anchor point is fully constrained, so we can close out of the Sketcher workbench, and we will pocket this all the way through to a depth of 5 millimeters. All right, so now that we've got that done, we can start in on our next panel here, and that's going to be the switch panel. So I'm going to begin first by renaming this. So this is our port access panel. And I'm going to hide this panel for right now. And I'm going to create a new body and a new sketch on the XY plane. And to create this next panel, we're going to create a base first. And so our base is going to be 20 millimeters in the horizontal and 8 millimeters in the vertical. I'm going to position this around the origin, and then I'm going to constrain it so that it's symmetric around the origin. And so that's the initial dimensioning of the switch panel. This will be attached directly to the Vetronics platform, so it will not move when the enclosure of the Vetronics deck is removed. So we're going to create these two anchor points here. These will be what we use to secure this switch panel to the mobility base. The outer diameter is going to be equal for both of these, and we're also going to make these two anchor points symmetric with respect to the y-axis, which has the happy effect of also making them collinear. Let's set the diameter of our anchors to 2.8 millimeters. And we're going to set the point-to-point or center-to-center horizontal distance to 10 millimeters. And the last thing that we need to do, we've got 1 degree of freedom here, is we need to set the offset from the bottom, and that's going to be 2.5 millimeters. And so with that, we have fully constrained the base for this switch panel. So we're going to close out of the Sketcher workbench, and we're going to pad this shape out to 7 millimeters. And now we're going to add a feature on the top here, and this is going to be a 3 millimeter panel that actually holds the switch. So we're going to reference this top edge here, and then with the rectangle tool, we're going to create a rectangle, but we're going to constrain coincident with the very end of that line segment there. So we'll use this tool here to do the job. And now we're going to constrain the vertical dimension to 3 millimeters. And so we are fully constrained. We can close out of the Sketcher workbench, and we're going to pad this feature out to 40 millimeters. There we are. And now we're going to look around at the front of our panel. And we're going to create a new sketch on the front of the panel face here. And we're going to create a profile that matches the toggle switch that we're using. So we're going to zoom in here at the bottom. And we're going to use the polyline tool. And we're going to come up about right here. And we're going to create a symmetric profile. We will fix up any horizontal or vertical constraints that were not automatically added. There we are. There's the basic outline. So we've got a line here, and a line here that need to have a horizontal or vertical constraint. That solves that. And we're going to take these two inside points and make them symmetric around the y-axis. We'll do the same thing with the two lower constraints, the two lower points. And we're going to do that once with these two outside edges here. And we're going to set the tab feature here. They're both going to be equal. And now that we have constrained this symmetrically, now we can set some dimensional constraints. So this tab, and one last thing, we want the bottom tab and the top tab to be constrained collinear. So we're going to we're going to click those two, and there we are. Now we've made it so that the tabs are collinear. Well, the edges of the tabs are collinear. All right, so our dimensional constraints, we'll put the top of this feature at 4 millimeters. Make this a bit easier to see. Okay. And we'll put the sides at 13.5 millimeters. And the point-to-point outer edge is going to sit at 8.5 millimeters. And then lastly, we want to set the thickness of this tabbed feature, and we're going to set that to 1 millimeter. And then we've got 1 degree of freedom, and that's going to be the position of our profile on the y-axis. I'm going to move this profile up a little bit because sometimes the lower part of this tab feature turns inside out when you try to constrain its position on the y-axis. So I'm going to select these 2 points here, and I'm going to set this to 11 millimeters. And that pulls the outline down towards the bottom and keeps any of these parts from inverting. So we're fully constrained. We have the correct profile outline for our switch, and so we can close out of this, sketch a workbench, and we can pocket this shape through. I'll accept that default of 5. Next, we're going to add a point, an anchor point for a 5 millimeter LED. It's 5 millimeter diameter. So we will create a new sketch on the front face. And let's set our anchor point here so that it is right on the y-axis. So we've got that anchor point there that shows that our circle is locked on the y-axis. We're going to set the diameter of this to 5.2 millimeters. And we need to reference this top edge here so that we can constrain where on the y-axis this is going to sit. So we're going to constrain this so that we have an offset of 10 millimeters. And so now we can close out of the Sketcher workbench and pocket this shape all the way through. We'll accept the default of 5. Now we're going to return to the back inside face of our panel here. We'll create a new sketch on this. And what we need to do is we need to create a shoulder around this hole that will keep the 5 millimeter LED from wiggling and pulling out. So we're going to reference this hole that we created, and then with the circle tool, we will create a circle that's coincident with that construction geometry, but the second circle we need to constrain with a diameter of 9 millimeters. All right, and so we're going to close out of the Sketcher workbench now, and we can pocket this new feature out to 2 millimeters. And that completes the switch panel. Now we're going to rename this one here, and we'll call this one just switch panel. And I'm going to bring back the port access panel. Now both of these parts will need to be rotated properly in order for them to correctly 3D print. Right now this one is sitting upwards along the Z-axis, and so trying to 3D print the switch panel in this position isn't going to work very well. So what we're going to do is we're going to transform this switch panel, and we're going to rotate it down by 90 degrees. So that the flat face sits on the build plate. I know that I'm looking down at the build plate because in the nav cube, top is facing up. So that means down is where the build plate is. So this is where the switch panel will print on the build plate with its flat face against it. Here we have a small problem because we have this mounting boss pressed down towards the build plate. So I'll accept that, and I'm going to rotate this access panel. And I want to rotate it 180 degrees. And with that, I'll accept that rotation. And now I have both panels properly rotated, ready to be imported into the slicer. Of course, you can do this rotation in the 3D modeling, the 3D printing program, the slicer programs themselves, but we do it here. That's just one step that we've got done in advance. So that completes the split back cover. By separating our rear plane into a fixed switch panel and a dynamic data port cover, we've protected our power wiring from constant flexing while still allowing for complete mechanical clearance around the Arduino's ports. Adding the vertical venting array is just the finishing touch to give our electronics bay a professional, manufactured aesthetic. In the next video, we will design the final puzzle pieces, the close-fitting rear stop blocks that attach to the mobility base, and the sliding latch mechanism that locks down onto the side panel flanges, securing this entire compression structure. Stretch your course, build your world. See you in the next one.